All right. Hey guys, Miss Lastly, Miss Margaret here. We are doing day 17 permutations. Hopefully you guys had a pretty okay time with yesterday's homework. Today is just going to kind of build on that topic of how many ways can you arrange things. But yeah, so I will turn over to Miss Margaret and we'll go through the notes.
Yeah, so like Miss Ashley said, today we're just looking at permutations. There's 3 different variations on this that we're going to look at today. And then that'll be it. There's some calculator stuff, so hopefully your homework won't take too long. Then yeah, okay, so a permutation is an arrangement of n objects. So this is, again, building off of yesterday and building off of that counting principle. And yesterday we talked about how many ways you can kind of combine things with the sandwich. So like you can have 120 different ways of having that meal that we talked about yesterday. So this is just kind of building off of that. The big thing here of n objects. The big thing here and the big thing to remember, especially when we get into Thursday, when you guys are going to have combinations and permutations, and all the different things together, is that with a permutation, order matters. And that is the big thing to remember here. So order matters. So like it matters if you have either A, B or B, A, but order matters. And that is the big thing to remember here. So in our example number 1 here, we have 8 horses. They're running in a race. Think Kentucky Derby, and that should be a question mark. If there's typos, sorry, I was having technical difficulties this morning, so if there's typos, ignore them. I'll fix them later. We have 8 horses running in a race, and we want to know in how many different ways the horses can place in the race. So obviously we would have 8 different places since there's 8 horses running in the race. So we would have 8 different places. So 1, 2, 3, 4, 5, 6, 7. So for this one, this is going to be very similar to kind of what we were doing yesterday, and the order matters, and this is just very similar. So in that first place, we can pick from all 8 horses. So we would have 8 different horses here that we could pick from. In 7th place, in 2nd place, sorry, this would be first, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th place. In 2nd place, since 1 horse has already won, we now have 7 horses that can take that spot. And then in 3rd place, obviously we have 2 horses that have already won, so we can have 6, and then so on and so forth. So it's just going to kind of go down like that. Now this should look somewhat familiar to Monday of last week. Since we have 8, 7, 6, 5, 4, 3, 2, 1, that is equal to 8 factorial, which means that the number of different ways that the horses can place in the race is 8 factorial. And I don't know what that is off the top of my head, but 8 math. It's a big number, so let's see. 40, 30, 320. So that is the number of ways that the horses can place in the race. So yeah. Okay, so now we're going to talk about what happens if we only care about the horses that come in 1st, 2nd, or 3rd. So if we don't care about the horses that come in 4th place through 8th place, we only care about the horses that come in 1st, 2nd, or 3rd. Now for this one, we have a formula, and it's going to look very similar to what we had for the binomial theorem last week. And there is a way that you can do this on the calculator if you would like. So it's going to look like this. So remember last week we had NCR. This week we have NPR, so P for permutation. And it is equal to N factorial over N minus R factorial. N is the number of objects. R equals number of objects you take out. And we'll do an example in a second, but really quick, I want to tell you guys just how you find this in your calculator. This works very, very similar to how you did the NCR last week. So remember, if you have an old calculator, that N needs to be in first, and then you go through the steps, and then you put in R and hit enter. If you have a new calculator, you're going to end up with the two little boxes on either side of P. But again, this is just math. You scroll over to the prob, and instead of hitting number 3, you're going to hit number 2. But other than that, it works exactly the same as the NCR stuff that we had last week. So yeah. Cool. Okay, so for example number 2, again, we have the same 8 horses running in the race, but this time we only care about the horses that are coming in first, second, or third place. So in this case, we are going to have an N. So we have 8 horses, so N would be 8. The number of objects we take out is how many horses we don't care about. So if we are looking at first, second, or third place, reverse that. The things that we do care about. So we have first, second, or third place, so we care about 3 horses. So R is going to equal 3 because you're taking out 3 horses. So you're going to have 8P3, and this is going to equal 8 factorial, and then 8 minus 3 factorial. And then from there, you can either put it into your calculator or you can simplify it by hand, but this ends up being 336 different ways that the horses can come in first, second, or third. Yes.
If you go back up to the original example where we had all 8 horses.
Yes.
If you only care about the first 3 finishing, right? So 8 times 7 times 6. The rest of it, the 5, 4, 3, 2, 1, is just 5 factorial, right? 5 times 4 times 3 times 2 times 1, right? So basically what we're doing is we're just taking away the 5 factorial. Well, if you look at the equation, n factorial divided by n minus r factorial, you're just taking 8 factorial and you're dividing it by 5 factorial and then simplifying. So it's the same kind of concept. So some people like to think of it as the formula. Some people like to think of it like logically, like what's happening, right? And basically what you're doing is if you have all the blanks filled out, like Miss Marker does, you can kind of just look at the 3 you want. If you only care about the top 3, then you can just kind of cross off the rest of it and just multiply 8 times 7 times 6, which is going to end up equaling 336. So the formula is nice, and your calculator does do it by itself, so that's really helpful. But just visually know like what you're doing, right? You're basically just taking away the parts of it that you don't care about. Like you don't care about who finishes 4th through 8th. You only care about the different combinations of first, second, and third, right?
Mm-hmm.
So kind of nice to think about. It's cool to have a formula, but you guys could also visualize this too if you wanted to. But calculators definitely make this stuff much easier.
Yeah. Okay, we have one more thing. Ooh, that is too big. One more thing to talk about, and then I think that's it for the day. Whatever. Okay, so now we need to talk about distinguishable permutations. Okay, so this is when, again, order matters. So like when you have the word banana, how many distinguishable ways can you write that? And the formula for this one is n factorial over n1 factorial, n2 factorial, and then nk factorial. Now n1, n2, all the way through nk, those are going to be the number of things that I guess repeat in your problem. So like if we look at the word banana, a and n repeat, and so that's what we're going to have there. So what happens is this is the total, n factorial is the total. So in banana we have 6 total letters, and then we have 1, 2, 3 A's. So this is going to be 3 factorial. And then we have 1, 2, n. So this is going to be 2 factorial. And then, again, you can just simplify. So we would have, that's not simplified, sorry guys, times 5 times 4 times 3 factorial. And then so we would have this, and this would all simplify to 60, which is significantly less than all the other ones we've been doing. But there are only 60 different ways that you can distinguishably write banana. Yeah. All right, let's do one other example. So I have the word Mississippi written here. Hopefully that's spelled right, because who really knows? Okay, so let's do this. Let's do eyes are going to be green or blue. That is definitely blue. So we have 4 eyes. We have 1, 2, 3, 4 S's. And we have 1, 2 P's. So when we go through and do this, we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total letters. And then we have the 4. So 4 factorial, 4 factorial, and 2 factorial. And again, you can expand that out and simplify. And that just ends up being this super huge 3, 4, 6, 5, 0. And that is the number of distinguishable ways that you can write Mississippi. Yeah. Did I miss anything, Miss Leslie?
No, that's good. Yeah, just, I mean, think about these, right? You don't want to, so if you reorder the letters in banana, right? If you just switch the first A and the second A, you haven't made a new word. It's the exact same word that you started with. So basically what we're doing with this is just taking away all the duplicates, right? So we can figure out, like, for banana, there are 60 different ways you can rearrange the letters in the word banana. In Mississippi, there are 34,650 ways you can reorder those letters. Now, we're not talking about reordering them so that they make another word. We just want to know how many ways can you reorder them and still get like a distinguishable or like brand new outcome, right? So basically, we're taking away the duplicates, right? We're just getting rid of the things that are happening multiple times.
Like switching the first I and the second. And the
right. Yeah. Right, exactly. Like if you switch the first I and the last I, you still have the exact same, it looks the same, right? So we just don't want to count those. So those are nice. Most of the time people generally get these ones. Just remember, count how many total letters, and then you're dividing by the letters that repeat. Yeah, pretty easy.
Yeah, that's basically all your guys' homework is. You have some word problems like the horse, and you have some words to reorder. Yeah, so that's about it for today.
All right, well, we will see you guys again tomorrow for some more exciting notes. But yeah, have a good day, guys. We'll see you tomorrow.